All right, let's start with exponents and we will kind of link it with radicals. Now remember, exponential rules. There are 3 rules. If you have something like this, you're multiplying exponents with the same base, you add up the exponents. If you're dividing it with the same base, you subtract the exponents. And if you have a double exponent, you just multiply your exponents. So these are the 3 exponential rules that we're going to use. And almost all of these are going to be one-step answers. So we just have to write them or rewrite them with a positive exponent. Five to the negative 4, first one. How can we make this negative 4 positive? Remember,
Move 5 to the power of 4 under 1.
So for A, it'll be 1 over 5 to the power of 4.
Mm-hmm.
You want to either throw it in the numerator or in the denominator to change the sign. Same thing. What about B? B is slightly more different. So if you have a fraction with a negative exponent, what you do is you turn that fraction upside down and the exponent becomes a positive. So for B, you're going to do it like this. You turn that fraction upside down and then the exponent becomes positive automatically like that. What about C? How can we make that exponent positive?
It becomes 2 to the power of 4.
Right. What about D?
You flip the fraction.
Yeah, so the sign on the outside stays where it is. Inside, the fraction flips upside down, and now the exponent becomes a positive exponent. What about E?
You do the same.
Yep, so it becomes 11 over 3 to the positive 1. For F, you're going to have to throw the 8 upstairs, becomes positive 1. You throw the 7 downstairs, becomes positive 2. And that's it. All right, most of these are also one-step answers. Remember, if you're multiplying, you add them. If you're dividing, you subtract them. Sometimes there will be a double negative, as we'll see in part C. What's the answer to A? So you add the exponents, right?
Mm-hmm.
So what does it add up to?
0.
0. So anything to the power of 0 is a 1. So the final answer here is 1. For B, it's going to be 6 to the negative 2. You just add them up. And if you want to make it positive, you throw it in the denominator. What's the answer to C? 2 to the power of what?
2 to the power of 13.
Yep. For D, it'll be 11 to the negative 8. And then you can throw that in the denominator. What about E? E is slightly trickier. So forget about what's inside the bracket. Let's say you had a to the power of -1. What would you do with this? How would we make this positive? The exponent.
You put it under 1.
You put it under 1. So same idea here. This would become a to the 1. So exact same idea here. It'll be that entire bracket, which was a before, now becomes -9 to the 4 and a positive 1. So it's just -9 to the 4. For f, you just multiply all three numbers. So 7 to the 6 times -2, -12 becomes 1 over 7, 12. And you're done. Cool? That's it. That's the idea. You either add or you subtract. It's not terribly difficult. Let's look at 3. It says, which is the greater power? 2 -5 or 1/2 to the -5? What do you think? I think if you were to convert it into positive exponents, you'll see the answer. For this one, goes in the denominator. 2 power 5 is 32. How do we make this exponent positive?
You flip it.
You flip it, so it becomes 2 over 1, which is redundant, so it's just 2 power 5, which is 32. So which one is bigger, left or right?
Right.
Mm-hmm. This kind of has to do with the parent function. Let me show this to you graphically. If you have 2 power x or 3 power x, anything when the base is bigger than 1, 2 power x, 3 power x, 4 power x, doesn't matter, 2.5 power x. The parent function looks like this. It always goes through the y-intercept of 1. All of these guys. 100 power x, 10,000 power x, whatever. Pi power x. All these goes through the y-intercept of 1. And as long as that base is bigger than 1, it's going to be an exponential growth. Similarly, when base is less than 1, like this. Now inside the base, they're all less than 1. The parent function looks like this. Again, goes through 1, but instead of growing, it decays. This is an example when the base is less than 1, is an example of an exponential decay. This is an example of an exponential growth. Exponential because our unknown is in the exponent, and growth because it's going up. Whereas this one is a decay because as the x values go up, the y values go down. So to answer this question, we're going to start here. 2 power x, 2 power -x. Now this is a transformation. What's the transformation that takes us from 2 power x to the 2 power -x? It's called a reflection. Is it on the x-axis or on the y-axis?
On the y-axis.
On the y-axis. So 2 power -x would look like this. 2 power negative x. So when the x value is 5, your y value will be something much less than 1. On the other hand, for this one, this is 1 over 2 to the power of x as is, but then if you do 1 over 2 to the power of negative x, it'll be a reflection of this curve on the y-axis. It'll end up looking like this. This is 1 over 2 to the power of negative x, which you'll see is equivalent to 2 power x if you flip it upside down and make the exponent positive. So for this one, when x is 5, the y value is much higher than 1, okay?
Mm-hmm.
So this was always going to win. Well, to the right of the y-axis. To the left of the y-axis, these values would be bigger on the y-axis. I'm not going to do all these. We've done it before. Let's try to do a difficult one, maybe this one. Start one by one, I guess. Let's start with this. Is there any formula that we can use to open this bracket? Like what happens if can we even open this bracket? What do you think? The question is, can we open that bracket or can we not open that bracket? The answer is you cannot open that bracket. Okay?
Mm-hmm.
You cannot open that bracket. You need to know what the exponent is here. It's negative 2 times n. Actually, we do know what n is. So let's just plug the numbers in. But as is right now, you cannot open this bracket. You need to know exactly what that exponent is. So let's plug in the numbers. So negative 2 to the power negative 1 plus 3 to the power negative 1 to the negative 2 times negative 1. So this becomes 1 over negative 2 plus 1 over 3 squared. Yeah, like that.
Mm-hmm.
So you can just do this in the calculator. 1 over 3 minus 1 over 2 is negative 1 over 6. And you square that, the answer is 1 over 36. And you're done. These are honestly all the same questions. So which one of these guys is correct? Well, neither of them are correct. So let's start one by one. Is the first step correct for Eric?
Yes.
Yes. This guy is wrong because he didn't add the exponents right. Is the second step correct for Eric?
No.
No, because why?
Because of the negative.
Yeah. So it should have been like this, and the final answer should have been 1 over 3. These two steps are okay, but it was wrong to begin with because of this. To here. The goal is to solve, it's an equation, it's an exponential equation. The goal is to solve for n. What is our approach? So think about 0.25. What is it as a fraction? How would you write 0.25 as a fraction? It's a quarter, right?
Mm-hmm.
How can we write 1 over 4 as 2 to the power of something? What would be the exponent?
1 over 2 to the power of 2.
Yes, it'll be 1 over 2 to the power of 2. And then when you move it up, the 2 to the power of 2 on the bottom comes over here like this. So what does n equals to?
-2.
-2, and you're done. So you don't have to use logs for this. You could. Logs always work as long as there's a solution, but if you don't want to use logs, you can just do it like this, as long as you can write both of them in the same base. Like all of these, you don't even have to use logs here. Let me just show you really quickly. The answer to A is -1. What's the answer to C?
0.
Yeah. The answer to E is -2. Sorry, N, it becomes N, but yeah. You just move it up. This one is a tricky question. It says if 10 power 2y is 25, determine the value of 10 power -y. This one's tricky for sure. All right. How can we rewrite 10 to the power 2y? Is there any other way? How about we write it like this? Check this out. 10 power y squared. Can we do this?
Mm-hmm.
How do we get rid of that square?
You square root.
Use square root. And it says y has to be positive, so it cannot be -5, yeah?
Mm-hmm.
So this becomes 10 power y is equals to 5. How can we turn this into this? We have 10 power y right now. We need it to look like 10 to the power -y.
You put it under 1.
Yep. So what is this equals to? So you can multiply both sides by that, okay? I'll give you 1 equals 5 times 10 to the -y. And we need to solve for 10 to the -y. So it becomes 1 over 5. So that's the answer. 10 to the -y is 1 over 5. It's not asking us to find y. If it did, we'll probably use logs, but you can just stop right here. Cool?
Mm-hmm.
So this one was definitely tricky. Math itself isn't too hard. You just need to know how to apply the exponent rules. Maybe we'll just do one or two of these. I'll start with this one. It simply says simplify. That's the entire question, simplify. So let's see what our strategy is. So you can see the base of A. You have multiple A's, so we need to combine it as one A. That'd be the answer. The answer is gonna be A to the power of something. So for the first one, we can't really touch it, so it's just gonna become A 10 power P times what happens if you bring that A to the same level? What's gonna be the,
Becomes a to the power of -1.
yeah, it becomes A to the power -1, and then you have a P, so it becomes A to the power negative P. Next step, you're multiplying them, you just add them up, right?
Mm-hmm.
There you go, that's the final answer. A to 10 to the minus 2P. The idea here is the same. You have x's, you need to combine those x's into a big X, into a singular X. So let's open this bracket. What does it become if you open this bracket? This one. So
Big to the power of 24 minus m.
good try, but that exponent also applies to that 3. So it'll be something like this.
Mm-hmm.
And then you have these two, you just combine them. And you're done. Cool?
Mm-hmm.
It's a two-step answer. Just open the brackets. If there's an exponent, it applies to everything inside. I did some of this yesterday. Don't know which ones to do. You see this question. You have a cube, you're given its volume. The question is to find the side length. What's the formula for a volume of a cube?
Side cubed.
So you can treat this as L cubed or something S cubed. And then you cube root both sides, right?
Mm-hmm.
And what is the cube root of that? 0.015625 to the power of 1 over 3. So 0.25 meters. So that's the side length. And you're done. It says use your calculators to determine the values of these two. Compare the two answers and what do you notice? Okay, what's our prediction? If we plug this into a calculator, what do we get? Look at the exponents. One of them is 4 over 3. The other one is 1.33 recurring or close enough.
Aren't they the same?
They're the exact same. So when we plug it in, we're gonna get the exact same answer. We can actually solve this. maybe. Let's see. So this is the same thing as cube root of 27 to the power of 4, right?
Mm-hmm.
Remember, the denominator becomes the index. What's the cube root of 27?
It's 3.
It's 3. And then we have 3 power 4, which is 81. So the answers to both of these will be 81. This one probably not quite because this needs to go on forever, right? You'll probably get like
Mm-hmm.
80.99 or something with this one. That's close enough to 81. Explain why this is possible to evaluate while the other one is not. Alrighty, for this one, you just have to think about it in terms of a fraction. What's 0.2 as a fraction? If you're not sure how to convert things into a fraction, right? Just start with the decimal portion. Just start with 0.2. How do we get rid of this decimal? What do we multiply this by?
100.
10. So multiply it by a 10. It becomes a 2. When you multiply it, you also divide it simultaneously like that. So it becomes 2 over 10, which is 1 over 5. So negative 100 to the power of 1 over 5. It's the fifth root of negative 100. Can we take an odd root of a negative number? Yes, we can. Odd root is good, okay?
Mm-hmm.
Let me just plug this in. Negative 100 to the power of 0.2. The answer is like negative 2.5118, which basically means if you take negative 2.5118, and if you take this to the power of 5, you will get negative 100. So that's why that is possible. You can take an odd root of a negative number. You can take the fifth root of negative 100. What's 0.5 as a fraction?
1 over 2.
1 over 2. That one's a little bit easier. Negative 100 to the 1 over 2. This means the square root of 100, which means you're looking for a number. When you multiply that number with itself, let's say it's x, when you multiply x with x, you get a negative 100. So you're looking for this number. Does it exist? Can you take the even root of a negative number?
No.
No, you cannot, because it's the same number, so they can't alternate in their signs. So if the first one's negative, the second is gonna be negative. We'll give you a positive number. If the first one's positive, the second one is automatically positive because they're the same numbers. That'll also give you a positive number. There's no combination here of possible numbers where you'll end up with a negative 100. So no, this is not possible. You cannot take the even index of a negative number. Odd is good, odd index is perfect, but even index is no good. Write 1 to 5 in radical form. So basically means write it with square roots and cube roots and whatnot. So how would we write this using index? What do you think? Think about it like this. We have 1, 2, 5, -2. But first, we're gonna cube root this thing. Like that.
Mhm.
What's the cube root of 125?
It's 5.
It's 5. What's 5 to the power -2? It's 1 over 25. Yeah?
Mhm.
Because it's 1 over 5 squared, which is 1 over 25. Right, so this one, you're gonna explain it to someone who may not be very rehearsed in exponents. So like someone on the street, if you met them, how would you explain this to them? So 4 cubed is 4 multiplied itself 3 times. What is the meaning of 4 to the power 2.5? How would you explain this is the question. Is it 4 being multiplied by itself 2.5 times? Would that make sense? What does that even mean, right? Like being multiplied half a time.
Mhm.
So it's not like 4 times 4 times and then like half of 4. Or like this is missing. That is not going to cut it. Think about it in terms of radicals. 2.5, what is that as a fraction? What's 2.5 as a fraction? Remember how I showed it? Like you first get rid of the decimal. To get rid of this decimal, you just multiply it by 10. When you do it on the top, you have to do it on the bottom like this. So it becomes 25 over 10, which reduces because 5 is divisible. It's going to become 5 over 2.
Mhm.
So how would you write this as a radical? So it's the square root of 4 to the power of 5, yeah?
Mhm.
So the meaning of this is you square root 4 first, and then you multiply itself 5 times. So the answer to this will be 2 power 5, it'll be 32. The answer is thinking of it in terms of a radical. Let's try a difficult problem, or that looks difficult. It's not terribly difficult. What's the square root of x squared?
X.
Cube root of 8 is a 2. Cube root of 27 is a 3. What about this one? 1 over 16 to the power of 1 over 4. What does that mean? It's the 4th root, right? Remember, index always
Mhm.
goes in the denominator of 1 over 16. What's the 4th root of 1 over 16? It's 1 over 2. Cube root of 1 over 8 is 1 over 2. Square root of 1 over 4 is 1 over 2. So the 4th root of 1 over 16, it's a 4th root because of the index. It's 1 over 2. So we have 1 over 2 minus 2 over 3. So you multiply this by 3 on the top and the bottom, becomes 3 minus 4 over 6. So it's negative 1 over 6. And that's the final answer for this one. 3 steps.
Mm-hmm.
The next one is the exact same thing. 3 steps again. What's the cube root of 1 over 8?
It's 1 over 2.
Fourth root of x4
It's x.
is plus 15. Fourth root of 16.
It's 2.
It's 2. So move this here. Move this here. Becomes negative x becomes positive x here. On the other side, we have 1 over 2 plus 15 minus 2. So x is going to become 1 over 2 plus 13, right? So it's 13.5 or 27 over 2. That'll be the answer, and you're done. Easy as that. So here we have a question. It says simplify. So we have multiple x's, multiple y's. We only want one x and one y as the final answer, and ideally with positive exponents. Let's do it step by step. Step 1, we're going to open the bracket on the numerator. Does this 3 apply to this 2?
Yes.
Yes. The exponent applies to every element inside the bracket, so it'll be 2 cubed. What's the power of x on the numerator? Negative 6 or 9?
9.
What about y? 8 or 6?
6.
6. Same thing on the bottom. It's going to become x6, y negative 8. 2 power 3 is an 8. And now we want to make the exponents positive. I'm going to throw this in the denominator. So you'll be adding them. X to the 6 plus 9. I'm going to throw this in the numerator. And again, because of the double negatives, we end up adding them, right? Like this. So 8y14 over x15. And that's going to be the final answer. It's not too bad. You just either add or subtract. Sometimes it becomes a double negative. Right here, again, we have 3 different x's. I guess the goal is to just have 1x as the final answer. What do we do in the numerator?
You add the exponents.
You're going to add the exponents. So if you add them up, what would you get here?
5n.
5n is right. And then you want to subtract this guy, yeah. But now here, be careful. This is a very common mistake. People just do minus 2n minus 5. What's wrong here? So when I subtracted this from the 5n on the bottom, I wrote it like this. There is a mistake here. It's a very common mistake. What's wrong?
The 5 shouldn't be negative.
Yeah, whenever you're subtracting something, make sure you put a bracket there. So it'll actually be like this, and when you open that bracket, the 5 will be positive. So you get x to the 3n plus 5. And now we can plug the numbers in. X is negative 3, n is 2. So negative 3 to the 6 plus 5 is 11. You can just leave it like that because the exponent is positive. Remember, the exponent doesn't have to be a whole number. It can be a fraction, but it will still apply to everything inside the brackets. You'll be dividing instead of multiplying. What's the cube root of 27?
3.
What's the cube root of a negative 3? So you just divide them. Cube root of a negative 3, just do negative 3 over 3, you'll get negative 1. Cube root of b12, you just divide this by the index. What's the power of b?
It's 4.
It's 4. Similarly, in the denominator, 1 over 2 means a square root. Square root of 16 is a 4. What's the square root of a negative 8?
It's negative 4.
Yeah. And then b will be 6, right?
Mm-hmm.
So here, the numbers are by themselves, 3 over 4. We're going to throw this in the numerator to make it positive. So it becomes a negative 1 plus 4. And we're going to throw the b in the denominator to make the b's positive. So it'll be 6 minus 4 like that. So the final answer will be 3a3 over 4b squared. And that's as far as you can go. And you're done. Pretty fun, right?
Mm-hmm.
Right here, again, the goal is to write it as one singular x. Right now we have two x's, so we need to find a way to combine them. What will be the first step? You can work from inside out or like outside in, it doesn't really matter. I'm gonna work from the inside out. I think it's easier. So let's write both of these as a fraction. What's the exponent of x on the numerator?
X to the power of 8 over 5.
What about the denominator?
To the power of 3 over 2.
3 over 2. We're dividing it, so we need to subtract. So it becomes, I'm lazy, I'm just going to use fractions. 1.6 minus 1.5. Like that. So this becomes x 0.1 cube becomes x to the power of 0.3, right? Like that, right?
Mm-hmm.
Which is 3 over 10. I guess you could write it as this if you want. And that'll be the final answer. Did that make sense?
Mm-hmm.
It's honestly not, it's the same thing. If you can do one, you can kind of do them all. Let's look for nasty ones. Gonna start with this one. Again, the goal is to simplify. Simplify just means you can only have one base for each letter. So here we have two A's and two B's. We can only have one of each. So let's figure out a way to simplify this. What would you do? What's the first step? There's multiple things you can do. I'm gonna attack the -2 on the outside. Let's say we want to make that exponent positive. What do we need to do inside to make that exponent positive?
You flip the fraction.
Yeah, you flip the fraction. Nothing else changes, right? The fraction is just flipped like this. Now let's open this bracket. So this becomes a squared b negative 3 squared, right? What do we get on the bottom? If you open ab to the negative 1, what do you get?
A to the power of negative 1, and then b to the power of negative 1.
Right. Now, to make the a's positive, you need to throw this up there. Becomes 2 minus negative 1, becomes 2 plus 1, becomes a3. To make the b's positive, you need to throw this down there. What's the power of b right now? If you throw
It's
b,
2.
yeah, 2. Finally open that, it becomes a6, b4. And that'll be the final answer. Here, what about this one? What would we do? First step. So there's multiple ways to attack this. What I'm gonna do is I'm gonna attack this exponent here. There's a negative exponent. I'm gonna leave everything on the outside because it's a positive exponent as is. But inside, it's gonna become 32x5 negative 2 x negative 1, 10. Like that. Sorry, this becomes a positive 2 when you throw it in the denominator. So that's a plus 2. Next, we're going to open both these brackets in the denominator. You will get 32 squared times x 10 times x negative 10, like that. Yeah?
Mm-hmm.
What's x 10 times x negative 10? It's 1. X 0 or just simply 1. So our entire expression becomes 1 over 32 squared to the power of 0.2. Yeah?
Mm-hmm.
So we can rewrite this as 1 over 32 to the 5th root. Remember, 0.2 as a fraction is 1 over 5, which means your index is 5. This is a 5th root. 5th root of 1 over 32 squared. The squared comes on the outside.
Mm-hmm.
5th root of 132 is 1 over 2 squared. The final answer is 1 over 4. So the entire thing simplifies to 0.25. Okay, let's try this one. So the outside exponent is positive. We'll just leave it there, 2/3. Let's work on the inside. Square root of 64, 812. What does that simplify to?
64a to the power of 12 over 2.
No, good try though. The root also applies to 64, right? It'll be 8a6. Square root of 64 is 8. Square root of A12 is 6. Similarly, on the bottom, you'll get a negative 9. Do we move the A6 down or A9 up?
The A9 up.
Yeah, so it's going to become 8A15 to the power of 2/3. Now look at this. I'm going to first do a cube root of A15. And then we're going to square it. What's the cube root of 8?
It's 2.
What's the cube root of A15?
It's a to the power of 5.
Yeah. And then we're squaring this finally, so the final answer will be 4A10. And you're done.
Mm-hmm.
It looks super difficult, but it's honestly, it's whatever. Let's try another one here. So the outside exponent is 0.5 positive, so we don't have to flip anything. 18 to the power of 1 over 6. Remember, you just multiply these two numbers, yeah?
Mm-hmm.
Becomes negative 3. Fifth root of 243, I think, is a 3. X2, like that. So that's step number 1. From here, it's simple. You're going to move the negative 3 down. It becomes 1 over 3x5. The square root. You can just leave it like this if you would like, yeah. Because you can't really do anything else with this. And that'll be the final answer. So here they've given us an equation, which is that volume of a sphere, 4 over 3 pi r cubed. Sphere is a three-dimensional circle. The first part says solve this equation for r. All right, so this is our equation. V is equals to 4 over 3 pi r cubed. How do we solve this equation for r? Any ideas? We only want r on one side, we want everything else on the other side. Let's do it step by step. Step 1, let's get rid of this 3. What do we do on both sides to get rid of that 3?
You multiply.
You multiply. What about that 4? What do you do on both sides to get rid of that 4?
You divide.
What about the pi?
You divide.
So you get 3v over 4 pi is r cubed. We're trying to solve for r. You cube root both sides. So therefore the radius is the cube root of 3 times the volume over 4 pi. Yeah?
Mm-hmm.
That's part 1. Part A. Part B says determine the radius when the volume is given. So is this our V or is that our R?
It's our V.
That's our V. So we're going to replace our V with that and let's see if we can solve our radius. So our radius is the cube root of 3 times the volume, 256 pi over 4 over 3. So that's V by itself. And then we had extra 4 pi in the denominator. Can we cancel out this 3 with this 3?
Yes.
What about the pi with the pi?
Yes.
Yes. So we're left with the cube root of 256 over 4, which is the cube root of 64, which is a 4. Therefore, the radius of this sphere is 4 meters, and you are done. Yeah,
Mm-hmm.
that's it, right? It's not terrible. Let's do this last one. Again, remember, this is being multiplied with this. If you're multiplying, you need to add the exponents. So on the top, it becomes x to the 2n plus 2, right?
Mm-hmm.
And then when you square root it, you're basically dividing the exponent by 2. You get x plus 1 on the numerator. This becomes this, which becomes this. The denominator, you simply divide by the index. You get x to the power of n. Move this up top, you get x to the n plus 1 minus n. The answer is x to the power of 1 or x. And that's the final answer, and you're done with this question. So again, not terribly difficult. All right, let's call it there for today.
Okay, thank you.
See ya.